Hello, everyone. Good afternoon, good morning, good evening, wherever you're calling in from. Glad to be able to welcome Haakan on the call today. Haakan's got a YouTube channel called Shotgun Diagnostics. We'll find a bit more about what he's getting up to in there in a minute. And also, he's doing some roundtable diagnostic discussion. Also, Haakan's been doing a lot of work with TopDon, so it'd be great to find out what he's getting up to there. And he's also got a bit of a case study kind of thing, waveform, oscilloscope stuff we can have a look at. Is that right?
Yeah, I have some various stuff I can share that I think is, just kind of interesting to check out and discuss. One that's kind of a case study. It's not really, we didn't solve it with the scope, but it was kind of an interesting situation where it's just a good discussion about the scope as a whole and kind of some of the things that you really need to remember about diagnostics in general, both with and without the scope. So yeah, I mean, I have all sorts of stuff I can share if we're interested and people want to talk about. So let me show you. So I captured that waveform specifically because I had a friend who was diagnosing a Tiguan that had an unusual fault. It was a really interesting case because he had a fault, and it was something to the effect of the rail pressure or the high pressure pump solenoid being stuck. So I'll share this now. So again, this was a case I helped a friend with, and he's a member of our group, and he gave me permission to share it. So this was the one he had. So it had rail pressure too low, fuel injection malfunction, a generic code. Now he scanned this with a VCDS Rostec, which I've had more and more mixed results on newer vehicles as far as the accuracy of the fault codes it's pulling. Now that's probably a function of after they switched over to UDS, there's been more and more muddy waters about what it's pulling for data. Valve for high pressure pump or fuel pump stuck open. That was the code that I thought was really interesting. Fuel pressure too low during cold start, and then valve for fuel metering. And this is actually mislabeled in the fault database. It says N290. It's actually an N276. So that was also funny. Improper labeling in the fault code. Now that could just be, because Volkswagen's lazy or who knows what the reality of it is.
Copy and paste, that's what it is.
Probably. Yeah, just lazy engineers, right? So he had a waveform like this. Now, he didn't label things correctly, and he also didn't get a capture when it was malfunctioning. The solenoid on the last one I showed you, that I just got current. I did not get voltage. I should have got voltage as well, but I only got current. So this was his key on engine off test of the solenoid on his. His was setting those faults, and he was not able to build high pressure fuel. So basically just low pressure in the rail at all times. He had this waveform, and if you look at the top trace, that's the current waveform. And I looked at that and I was like, what the hell is that? Okay, that's not what I was expecting at all, right? So if you follow the way that Volkswagen has done it, earlier on in their production, the vehicles were high pressure pump solenoid had a fuse and then a ground control from the ECM. Then they changed to dual modulated from the ECM. So power and ground both modulated directly from the ECM.
Mm-hmm.
Now, that one that I showed previously was a 2017 Golf Sport Wagon with a 1.8 EA 888 platform. It's a Generation 3. This is an EA 888 platform, Generation 3 Baker, which is the last revision of the EA 888 platform. They changed the control strategy for the high pressure pump solenoid drastically. It is a much lower current than I have ever seen. And I literally asked him like 5 times. I'm like, are you 100% sure you've got this set up correctly?
Well, yeah, it's like not even half an amp, is it?
Yeah, it's nothing. It's literally nothing. And I'm like, that's enough to move the solenoid and close the valve to get it to build pressure? I just kept scratching my head going, I don't buy it, right? So anyway, he had this fault. And I said, he sent me the waveform, and he's like, well, it's not faulting when I'm capturing the waveform right now, but I don't know what's going on with this. It's really odd. And I'm like, well, that's a bizarre waveform. The voltage doesn't look so weird to me, but the current is very weird to me. I was expecting much higher kick when it first engaged. This was when it was running, or excuse me, when it was key on engine off self-test. So then here's the signal from the one I had, obviously, with rail pressure versus high pressure pump current. So you can clearly see it's modulating it a completely different way. And then I looked at how it was wired, and I'm like, okay, it's wired the same. It's directly to the control unit on the Golf, the EA 888 3. And then it's the same on the Tiguan. It's straight off the ECM. It's both sides are modulated on the EA888B, but the control strategy is different, and it's two different ECMs. So the Golf Sportwagen is a CMOS 18.1, which is a Siemens system. And if we go on to Irwin, which is the OE site, we can actually see the generations labeling of the engines. So I look up the Golf variant, and it's a generation 3 EA888. And then I go in and I look up the other one. It's a 3B. So I can see it's a different generation, but also look at the ECM control. It's a Bosch system. It's a Bosch MG1 control unit instead of a CMOS 18.1. So we have two different control units. So again, this was one of those situations where I was like, well, we really needed a known good off a vehicle where it was exactly the same control circuit. I took it for granted that it would be the same because it was a 2-year difference. And I was like, God, they couldn't have changed that much in 2 years. Oh yeah, they made a huge change. We dug in deeper, and I have the capture from it running, and I probably stupidly didn't put it on here. So I said, okay, here's just the pieces of information that I dug out after doing some further reading. I said, we don't have a known good. I don't have one I can provide. There was nobody else in the groups that he had talked to that had one, which now we have a known good because he captured it after we fixed it. An overlay harness fixed it. I told him, look, we don't have a known good here, and this is a circuit related fault. My first thing to do is run a jumper harness directly from the high pressure pump solenoid back to the ECM, run an overlay harness for test purposes, see if it fixes it. Sure did, fixed it.
Yeah.
So, and then of course he did a more permanent solution with the wiring, but it was just interesting because I was like, well, normally the scope would have helped us and we could have diagnosed this if we had had a known good, but we didn't. And it was an odd control strategy I've never run across until now. So I was like, well, I don't even know how to look at this waveform productively and be real clear about what's wrong, aside from the fact that he was pretty sure he didn't catch the glitch in the action or in the act. And of course, if you don't catch the fault, then what are you supposed to do?
Yeah, it's difficult, isn't it? Yeah, so.
It is. Of course, Volkswagen's real vague with their fault codes. They don't give you a whole lot. P053 was one of the only ones. That P0087. This was the one that I thought was meaningful. This is all in their generic OBD fault manual, so you can get these in their service information. They don't have all the codes. They have some codes. The other thing I will tell you is sometimes if you don't find a fault code in the manual for the vehicle you're working on, find another model that has the same engine and download the fault code manual, and they will have the fault code in a different one. Now, the fault setting criteria could vary a little bit, but there's a very good chance if they have the same control unit, then the criteria will be the same, right? Because they're running the system the same way. They could vary a few things here and there, but overall fault setting thresholds are usually going to be the same from what I've seen. So anyway, this is the only data I could find. So I was like, okay, it says low side sensing less than a volt and high side sensing signal voltage 5 volts. So anyway, it's telling you the when it's looking for the problem, essentially.
Yeah, that's what will set the fault. Yeah.
So he didn't catch it in the act, which was unfortunate. Like I said, overlay harness is what fixed it. Here's the waveform after it's fixed. This is running. Essentially, we've got ground control on the bottom here because you can see it's dropping and it's pulling it to ground and staying on ground on the negative controlled modulated side. And then the blue at the top is the positive modulated side. So you can see it's real interesting. It starts at about 5 volts. And then when it activates the circuit, it jumps to 12 or battery voltage.
Yeah, they both start at 5, don't they?
It's really pretty interesting. So yeah, you see some really interesting behavior out of this. But it was just, it's fascinating to see. But even after all of it's fixed, look at the current waveform. It's like maximum 300 milliamps. It's nothing. And I just went, man, I've always been of the mind that we have to have at least some level of current flow in order to have some work being done. But the fact that they're modulating it and accomplishing the level of work required mechanically with like 200 milliamps, that's wow. I don't know. That blew my mind. That's why I questioned it like a half a dozen times. And I'm just going to say, I'm still not sold that this is correct. I still want to go get one of these cars that's healthy and nothing wrong with it, because I'm just that stuck on this. I'm still kind of going, something smells funny still to me. And Hans is a really smart guy, so I'm not trying to throw him under the bus in any way, shape, or form, right? I got to see it with my own eyes. But it is fascinating, regardless of whether or not this ends up being that's how it works. It's definitely not what I would have expected out of it, right?
No, yeah, it's a really low current, really low. Maybe the way it works is some sort of mechanical, like multiplier, like leverage kind of
Maybe. I mean, I
thing
don't know.
going on.
I haven't looked at the high pressure pump on them at all either. So what I'm really hoping for is that I could find like a wrecked one somewhere. It's too new. So all the U-pull parts places around me have older vehicles. They usually don't have anything like, well, I think the generation 3B of this engine started in either 18 or 19. So I'd have to get a pretty new vehicle that's been wrecked to get information from. So what I really like to do is get a hold of one, get a high pressure pump off of it, dig into it, take it apart, look at it, and see how it's constructed to see if it's different. But the other fascinating thing is the published information talking about the solenoid resistance for the high pressure pump actually lists the solenoid resistance the same as the generation 3 and the generation 3B, which that can't be correct because based on current flow, that's not possible. Solenoid resistance cannot be identical. That's not going to work from an Ohm's law perspective, right?
I suppose it depends on how it's been pulsed, because we're PWM, aren't we?
We are, yep.
So if the other engine pulses the same solenoid at a different duty cycle, then it would be a different current, wouldn't it?
I will go back and get voltage and amperage on the 17 Golf Sport Wagon to find that out definitively, because I do have, that's my parents' car, so I can have that whenever I want. So I will go back to the well and find that out for us.
Yeah.
I mean, in the current waveform,
and also
like
checking the physical resistance, because like I said, copy and paste at that level is rife. They all do it.
Oh, yes, it is. And so, I suspect that's what it is. So I thought this was a really interesting case with this Tiguan. I will go back and get the information, the voltage and the amperage off of the Golf Sport Wagon, and I will share it. And then if I do get a hold of generation 3B EA888 engine, I will go back and get a known good off it myself just to be rock solid. I mean, I believe Hans, right? He's a very good diagnostic guy, and he does a great job documenting. So I'm not doubting him for the most part, but I do know that he does have a manual setup Pico, whereas mine is an auto ranging clamp. So there's less potential for error. Also, like, what if his battery was weak on his clamp, right? Now, the auto ranging 4425A, it's a powered probe. You can't have a low battery. So the ability to have error in your signal from a result of the equipment, non-existent, really, unless you drop your clamp on the ground and break it, I guess. Hopefully that doesn't happen. You'll be a very sad person if that happens, because, they ain't cheap to replace. So I'll share a case study on ADAS with you guys if you're interested in that. I think it was an interesting one. So this one was a technical call I took on the TopDon hotline. So I have to take the level 2 calls for TopDon. This was a body shop that called in, and they said that they could not get the rear blind spot system generically to calibrate after they had a collision in the left rear. So basically, the blind spot module resides back in the bumper here, and it is responsible for warning the driver if there is a vehicle in the blind spot, which hence the name. So this is just kind of an overview of what I like to look at from a diagnostic perspective. I'm really big into collecting data, kind of like my friend Mike that I mentioned. I really like to do a lot of data collection before I go far into things. I think it's really makes a big difference in my ability to understand things. And usually when I don't do that is when I get burned. Anytime I skip some of these steps or I get all jacked up and excited about diagnosing it, and I do that sometimes because I legitimately like doing this stuff. So I get a little bit giddy sometimes and get too excited and lose my focus. And then that's when things come off the rails sometimes. So I try to not do that. So that anyway, I go through these steps and try to do these things to collect data for me. So what did I do? If you guys have PartsLink 24 over there, I would strongly recommend it. It is probably one of the best sites for identifying a European vehicle. Now, I believe in Europe, you also have access to the Mercedes-Benz parts catalog. In North America, they will not turn it on for us because Mercedes-Benz USA is really not very aftermarket friendly. But I do believe in Europe, they do activate it. However, PartsLink 24 is a great resource for being able to see the build sheet of the vehicle. So this becomes valuable on a lot of vehicles. It used to be primarily European in my experience. It's become a bigger deal on domestic and Asian vehicles now too. What I like to do with any kind of vehicles, I like to verify what it is I have in front of me. And then I like to look at the level of equipment. So on Volkswagen, this is very important, in my opinion. I think it's crucial to making sure you don't screw up your diagnosis. So I pulled the VIN and I dumped it in PartsLink, and it shows me it has the blind spot monitor. Now, the other key about this is the PR codes, which we see. These are these 3-digit letter number combos. These PR codes also will appear in the 1,000-page or 2,000-page wiring diagrams. So if you download the wiring diagram from Irwin, the factory website, and you do Control F on Adobe Reader, you can search the PR codes sometimes and find the system wiring diagram for that system much faster. And then it'll also find every instance of that PR code in the entire wiring diagram, which is valuable because you might have multiple build date splits for the wiring diagram. Anyway, there's multiple different systems on as far as the camera goes, which can affect the wiring on this one. So I found that there is different systems for cameras, so I highlighted those on the bottom right as well. So then I like to do a pre-scan on every vehicle I work on. I will baseline the vehicle to see how it's doing, what's wrong with it in its totality. A lot of guys who do ADAS have a propensity, many of the aftermarket scan tools have what they call an ADAS scan, and all it does is scan just the ADAS related systems. That's a really dangerous proposition because you can miss things in other systems which can inhibit function of the ADAS related symptoms. So I tell every shop I train, no, you need to first do a full system scan of everything, baseline the health, and then after you've remedied anything that could potentially interfere with ADAS, then you can do an ADAS specific scan for documentation purposes to show your customer to make sure that they know what the health of the ADAS systems were before and after you work on it. ADAS systems that need to be calibrated do not necessarily set a fault code if they need to be calibrated. So there's a misnomer out there that there's a lot of people who believe if it's not setting a fault, it's good to go. That is not correct. Each of the manufacturers sets forth specific criteria for when a calibration is mandated. There's a website in North America called iCar, and they have a lot of information available, much of which is free, that will tell you, if you look it up by year, make, model, when a calibration is mandated based on the manufacturer's specific creed. So the manufacturer will set it forth. iCar collects it all into one central website, and you can look it up there. So anyway, I told the shop, look, there's so many faults. And whenever I see a vehicle that has a ton of U codes and a ton of voltage related codes, the first thing I think is foundational electrical problem, right? Battery problem, voltage problem, something is going on here that's pissing this vehicle off and causing it to set all these codes. So I said, all right, let's look. Now, many of the scan tools that I worked with have a voltage display PID right up in the corner of the scan tool that you can see at all times when connected to the DLC. I picked up on that right away and I said, whoa, your voltage is real low. We're like already dropping below 12 volts and we've been connected to this vehicle for like 30 seconds. So I said, let's get a charger on this car. And I don't mean a regular charger, I mean a power supply. There's two very distinct versions of battery chargers. There's regular battery chargers where they do variable voltage and steady current. That's a conventional battery charger. And then there's a power supply style charger, which is what you need to use for programming and diagnostics and ADAS calibrations, which holds a steady voltage and varies the current in order to maintain a steady voltage level. Now, each of those power supply style chargers has different capabilities, right? Some of them can output you can modulate and change the set voltage or the voltage set point. So you can say, hey, I want it to hold it at 13 flat or 14 flat or 13.5. You can choose. And some OEMs are more picky about what voltage they like. But suffice it to say that if you're trying to memorize a learned value like an ADAS calibration, you need that voltage to stay steady so the control unit is happy. So a steady power supply will do that. And so you want to make sure you have one of sufficient amperage capabilities. TopDon does make several. They make a 30 amp one, which I think is very good for ADAS calibrations, wheel alignments, basic key on engine off testing. That one does 30 amps, and that's the TopDon Tornado T30000. And that one's nice because the cable's real low profile, so you can snake it under the hood and shut the hood all the way without crushing the cable. So that's real good for those. But if you're doing hardcore diagnostics or you're doing programming, you usually need more than 30 amps, or a lot of the newer vehicles will. So they make a T90000, which puts out 90 amps, up to 90 amps, obviously. And that one is designed more for, the heavier duty operations. Now, there are still some brand new BMWs that will draw more than 90 amps during a programming event. So you need to be aware of what vehicles you're working on and find out what is the maximum amperage they're going to draw when they do this, and make sure you get a power supply that's going to do the job, right? And the TopDon may not meet the needs. You might need something higher powered. So I said, hook one up. They did. They had the T90,000. So they hooked up the T90,000 and they set it to 13.5, 13.8, whatever. The T30,000 just defaults to 13.8 and you can't change it. So that's the default value. But they got it hooked up. We cleared all the faults and lo and behold, look what came back. Only 2. The one fault code that comes back on literally every Volkswagen, because I've never met a person who actually does activate the satellite radio. So you'll always get that fault for satellite radio deactivated. And then the only other fault we had was blind spot recognition warning lamp. So why won't it calibrate? So here we had blind spot control module. It says we don't have to calibrate it all the time. Sometimes it will self-calibrate unless there's a fault code, or unless it's 2020 and newer, in which case it always self-calibrates. So in the ADAS world, there's a lot of, the vernacular is now basically static calibration and dynamic calibration. Static calibration refers to we have to physically use a target and set the vehicle up in a specific controlled environment with specific controlled distances and circumstances. Essentially, we need to use a specific defined geometry to put the target in a specific location and then activate the control unit in the calibration mode in order to get it to calibrate, right? On a dynamic calibration, either the vehicle will automatically relearn it by itself and no intervention by the user is necessary, or we will go into the control unit, click a button to activate dynamic calibration function, and then we will drive the vehicle through a predefined set of circumstances in order for it to self-calibrate. So many of the manufacturers are making it so you can dynamic or static calibrate. They're adapting it so it can be done both ways on newer vehicles because dynamic is faster. However, dynamic is not as accurate, but they've decided that dynamic is good enough for a lot of circumstances. However, if you live somewhere where rain or snow is a factor, dynamic may not be feasible in many circumstances. So then you would need to be able to do a static in a controlled environment. Anyhow, that's what we determined. This is a 2018, so we know that if there's no fault, it would self-calibrate. If there is a fault, we need to calibrate it after we remedy the fault, right? So then I looked up the self-study program, which we talked about before with Volkswagen. So this is just referring to blind spot monitoring. You can see that the beams being projected out are coming from the bumper, which is a little different. Some vehicles, actually, the radars are in the mirror itself instead of actually in the bumper. Kind of depends on each vehicle manufacturer. However, we see in the pictures on the right here that the warning takes place in the mirror. So the big thing I've learned about ADAS systems is it's kind of like, when you go to the doctor, a lot of doctors are very compartmentalizing about the human body, but in reality, the human body is one cohesive unit. And if something is broken over here, it can affect things over here. So in this particular case, we have a light burned out, essentially, is what the fault code says, or a short in that circuit, or something of that nature. So the health of the system is not intact, right? The warning light is part of the total system health, and the warning light is not functioning on the left front mirror. So that tells us we need to fix that fault before the system will calibrate and work normally. This is just a little projection of the beams that come out from the bumper on the left here, the yellow. It's showing you the area that's monitored by the system. We need to have some anticipated perception of what the system will work like when it's fixed, right? We need to know, what is it going to do when it's normal? What is it going to do when it's fixed? So then I went and looked at the wiring diagram. Now this is funny because the wiring diagram is actually wrong. If you look real close, and I'm not going to try to dig in, but essentially they've got it. This is the mirror LED on the bottom left is VX4. And then we've got the blind spot module on the left rear, which is J1087 in the top left, well, top right, I guess, technically. The wire colors are all correct. And if we look at the wiring diagram, in theory, the red blue should be power and the blue white should be ground. But if you follow all the traces on the track wiring diagram, the red blue actually takes us to another ground. It's actually screwed up. If we follow track 26 over here, look where 9 picks up on 26. it actually says, or maybe I followed that wrong. I might have followed that wrong. No, I followed that right. 26 right here in the, sorry, brown blue. I read that wrong.
Yeah, you're looking for the
blue.
box with 9 in, yeah.
Yeah. So you follow it to brown blue, and that goes actually to a ground. So it can't have 2 grounds and work, right? That's not how that works. So they drew it wrong, as a matter of fact. It's supposed to be, I think what is supposed to be here is it's supposed to be the brown blue maybe is supposed to be the ground, and maybe the blue white is supposed to be. Suffice it to say, it needs to have a power and a ground to work, right? So I told the shop, look, there's a couple of things you can do here. This vehicle is hitting the left rear. The most likely scenario is we have a broken wire somewhere between J1087 and the bumper and the pass-through connector, which is this TTVL, which is a pass-through connector at the door. So I said, run a test harness from the door connector back to that J1087 and try to clear the fault and see if the mirror warning light will come on. And I said, you could probably bidirectionally control that warning light as well to test it. And I said, do that, see if the fault will clear. And if it does, then do a static calibration on this system. And he said, okay. This guy was actually very sharp, much sharper than actually a lot of the mechanical shops I talked to. And he understood exactly what I was talking about when I said run a bypass harness and see if it fixes it. He ran the jumper harness and it did actually fix the vehicle. So he did not have to replace the module. He repaired the wiring and he did calibrate it and it was fine. So I also sent him the information about how the system worked so he would know how to drive it, because after you do a calibration, you want to drive the vehicle and make sure that the warning light comes on when you have a vehicle in the blind spot on both sides to make sure it's working. So that's exactly what he did. And funny that it ends up being another harness issue since that's 2 that I talked about that did. But I like to tell guys all the time, hey, the fastest answer if you have a circuit fault is run wires from one end to the other and bypass everything else, right? I mean, that may not be your permanent fix, but holy cow, is that an efficient way to find out what's going on sometimes? I mean, it's
especially for intermittent problems.
Yeah. I mean, just run a test harness. It's easy enough to do a lot of the time. And so anyway, a couple of cases I just wanted to share. That was something from, we have a vendor that sponsors my training class. So I like to put that up there, but yeah, those are the 2 I wanted to share that I thought would be good. And like I said, I do a lot of Euro cars. So it's fitting that I come on a group that's got a lot of European attendees, because at least these are vehicles you guys might actually see.
So yeah, thanks for sharing that. I mean, thanks for coming on and sharing some of those case studies with us.